When ranking breaks, guessing wastes days. We'll build an explain-driven debugger so you can see exactly what boosted, what matched, and why result number 1 won. You have a search problem that looks right but behaves wrong. You tweak weights and hope for the best. That wastes time and risks regressions. By the end, you will be able to open the score, read the parts, and trace which term or boost tipped the balance. I'm Professor Pi, teaching search and IR with simple Python. Elasticsearch Relevance debugging is the practical art of turning mystery scores into a clear story. When results feel wrong, you want to know which field matched, which term carried weight, and whether a boost or a feature changed the order. People reach for the Explain API and feature logging when they need surgical fixes, not shotgun tuning. At a high level, the Explain API gives you a human-readable breakdown of how Elasticsearch computed a single document score. Feature logs capture per-query features that you can feed into models or simply inspect. Imagine a product catalog where a query matches both title and description. Explain shows how much each field contributed. Feature logs tell you the numeric features behind that decision. Together they let you pinpoint fixes and measure impact. We will build a tiny workflow that creates an index, indexes one seed document, calls explain, runs a regular search to inspect scores, applies a title boost to re-rank, and finally profiles the query to see clause-level costs. This keeps the example focused and repeatable, so you can map it to your catalog without fear. This snippet initializes a local Elasticsearch index and loads one seed document. It creates a simple mapping with a title field and a body field, so we can see field-level contributions. The code uses the Python Elasticsearch client to create the index, add a single document with a short title and a short body, and refreshes so the document is immediately searchable. Key lines set the index name and mapping. Then call index with a document ID and the document body. If you change the analyzer or the mapping, you will change how terms match and how term frequency is measured, which directly changes later explanations. Now we will check why the seed document actually matches a query. This snippet uses the Elasticsearch Explain API to verify why a document matches. It sends the same query you plan to use and asks Elasticsearch to explain the score for the seeded document ID. The explanation is a nested structure that names the matching clauses, shows their individual scores, and traces term statistics like term frequency and inverse document frequency. The important lines build the query object, call the explain endpoint for the index and ID, and then print the explanation tree. Reading top to bottom, start with the overall score, then follow the named clauses to see which field and which term contributed most. If a boost is present, it will appear as a multiplier in the tree, and lowering that boost will reduce that branch's contribution. Next, we will run a search to see the full ranking and the raw scores. This snippet runs an Elasticsearch search to show score-based ranking for the query. It submits the same query, but asks for the top hits, including each hit score, so you can compare documents. The code builds the query, sends it to the search endpoint for the index, and iterates the returned hits to show the ID, score, and source fields. Look at the scores column to see the numeric separation between hits. If you increase the size parameter, you will inspect more candidates. If the top hit score is only marginally larger than the second hit, that tells you small adjustments to boosts or analyzers could flip the order. Now, we will try a simple re-rank. Favor matches in the title field. This snippet boosts the title field in an Elasticsearch multi-match to re-rank results. The query lists fields with a boost applied to title so title matches receive multiplied weight. The code builds a multi-field search with fields like title boosted by a number and body with default weight. Then submits the search and inspects scores. The decisive lines are the fields array where title appears with a burst factor, and the search call that returns reordered hits. Increasing the title boost makes title matches climb, but if you set the boost too high, you may lose recall for relevant items that match only in body. Finally, we will profile the query to understand cost and structure. This snippet enables the Elasticsearch Profile API to log per clause query structure. It wraps the same query with profiling enabled, so Elasticsearch returns timing and execution details for each clause. The profile output shows how much time each clause spent, which clauses created the most work, and how many documents each clause visited. The key lines toggle profiling in the search request, then parse the profile sections per shard and per query phase. Use this to find expensive clauses, or to verify that a scoring clause runs in the order you expect. If a clause is unexpectedly slow, consider changing analyzer settings or pre-computing features. Mapping this toy workflow to a real system is straightforward. Replace the single seed document with a slice of your product catalog. Keep the same steps. Index a small set, call explain to validate, run normal search to see scores, push a field boost to test re-rank, and profile to find hotspots. This lets you iterate quickly before you change production settings. Recap. It is a practical workflow to inspect and fix relevance. Use explain when you need to know why a single document scored the way it did. Use boosts and the profile API to test re-ranks and to find expensive clauses. One caveat. Overboosting a field can improve precision but harm recall, so always validate on a set of queries. Next step. Tune BM25 parameters K1 and B on the index, and rerun the explain workflow to see how the term frequency and length normalization changes moved scores. If short, practical IR helps, subscribe and watch the IR videos.